Well, my presentation is about rocks of Earth, part one. It's about igneous rocks. The reason why I'm giving this is because I'm just a mineral collector, although I did it for 50 years now. But it wasn't until one of my friends who just started in mineralogy asked me where the minerals come from, how do they form, and things like that. And I never paid that much attention to it. So I delved into the geology about rocks, and I was amazed by things I did not know. So I'm going to give you this presentation to see if you can learn something from it. Rocks. Well, what are rocks? Rocks are natural materials from which the Earth's crust is built, and they are formed by geological processes and are classified into three main groups: magmatic or igneous rocks, which is the one I will talk about today, sedimentary rocks, and metamorphic rocks. Magmatic or igneous rocks. Well, igneous rocks is a rock that is formed by solidification of magma if it's below the surface, or lava on the Earth's surface. In the first case, we speak of deep or magmatic rocks, and in the latter case of extrusive rocks. Magmatic rocks, of course, they have to do with magmatism and volcanism, because when magma reaches the surface, it causes volcanism. The rocks that are created are called volcanic rocks, and that is named by the Roman god Vulcan, who was a smith, apparently. Magma that flows over the surface is called lava, and when lava solidifies, an outflow rock or extrusive rock is formed. So outflow rock or extrusive rock is therefore both a volcanic rock and an igneous rock. Again, magmatism and volcanism. Most magma does not solidify on the surface though, but inside the Earth, where it forms bodies of igneous rock called intrusions or plutons. The type of igneous rock from which they are composed is called deep rock or plutonic rock. Plutonic comes from the Roman god Pluto. So the Romans did have their say in this. And by far the largest part of the Earth's crust consists of plutonic rock. Magma is formed by the partial melting of rock, it's called a melt, in the lower parts of the Earth's crust or directly below in the mantle. Magma is often lighter than the rocks at that depth, causing it to move upward. It penetrates the overlying rock. There it can form large reservoirs, which are called magma chambers, that slowly solidify, mix with each other, are supplemented by new magma from the mantle, or move further upwards over time. During these processes, the magma can change significantly in chemical composition. These changes are called magma differentiation. They ensure that igneous rocks can exhibit a wide variety of chemical compositions and minerals. Cooling of magma causes crystallization to occur. Most magmas are a mixture of molten rock, which is called the melt, and crystals, which are called phenocrysts. The crystals usually sink to the bottom of a magma reservoir or float in a layer on top of the magma. This allows them to be extracted from the magma. As a result, the magma has acquired a slightly different chemical composition due to crystal fractionation of the elements present in the minerals in question. On the right, you see a flow chart, and the cooling process takes down and where the minerals form in different temperature grades. After the crystals have settled, the melt can rise further while the crystals remain in the magma chamber. Roughly speaking, mafic minerals, that are minerals that have a higher concentration of magnesium and iron, will crystallize at higher temperatures and pressures than felsic minerals, which have more silicon dioxide in it. When magma moves upward, it will therefore get an increasingly felsic composition. The sequence of minerals is described by the Bowen reaction series, which you will see on the right-hand side of the screen. The Bowen's reaction series contain two series, discontinuous reaction series and a continuous reaction series. In a continuous reaction series, you will see that the change takes place in the feldspars. It starts with calcium plagioclase to sodium plagioclase and to potassium feldspars. On the other hand, you see the olivine forms first, then the pyroxene, amphibole, biotite, and then the muscovite and quartz. Now we turn our attention to volcanoes. Well, a volcano is an opening in the surface of the planet through which molten rock, magma, comes out as lava, gas, and solid rock debris, called tephra. The moments when material is ejected by a volcano, the moments are called eruptions. There are different types of volcanoes: shield volcanoes, cinder cones, strato or dome volcanoes, and caldera volcanoes. A shield volcano, is pictured on the right-hand side, is a type of volcano that has flat slopes. These are formed by eruptions that release mafic lavas. Because mafic lava has a lower viscosity, it flows more easily than felsic lava, it can flow quickly over large areas, and volcanoes with a small angle of inclination are formed. Examples are the Mauna Loa in Hawaii and the Skjaldbreiður in Iceland. So relatively low volcanoes. Cinder cones, scoria cones, and pyroclastic cones are one of the simplest volcano types. These are frequently found in volcanic landscapes all over the world. They are not famous or notorious because their eruptions cause little damage. Typically, the cones develop in groups, and they are common on the slopes of stratovolcanoes and shield volcanoes. Okay, then the stratovolcanoes. A stratovolcano is a tall cone-shaped volcano that is made up of layers of solidified lava and tephra. Stratovolcanoes have relatively steep slopes and are characterized by regular explosive eruptions. The composition of lavas from stratovolcanoes is relatively felsic, so rich in silicon dioxide. And outflow rocks formed by stratovolcanoes are andesites, basalts, and rhyolites. Another cool fact is that the most stratovolcanoes reach altitudes above 2,500 meters. And the last type of volcanoes are the calderas. Is a large ball-shaped crater formed by volcanic activity. They are formed when large amounts of pyroclastic material are ejected by a volcano, causing the roof of the magma chamber to become unsupported. This causes the roof to sink and fall into the magma chamber, and thus creating a kind of a bowl which then can be filled with water. The classification of igneous rocks. The chemical and mineralogical composition of igneous rocks forms a continuous range, in which every dividing line is arbitrary, so it's not that easy to differentiate between the different igneous rocks. Classification of plutonic rocks based on minerals is done by means of a so-called QAPF diagram, and at the vertices are quartz, Q, potassium feldspar, A, plagioclase, P, and feldspar substitutes, F. You see a lot of names in there, among which the monzonites, rhyolites, granites, all kinds of rocks. Another classification of rock is based on their composition. Is it felsic, acidic and silica rich? Is it mafic, low in silica? Or is it in between, either feldspar rich or intermediate? But also on the structure, such as is it fine-grained, coarse-grained, or even has another texture like glassy. We will be coming into these types when we continue with this presentation, which I will be doing from A to Z in an alphabetical order, and it's by no means complete. And it will entice both plutonic and extrusive rocks. The first of them, well, first one is an andesite. Andesite is a dark, fine-grained extrusive rock. If it is porphyric, it contains phenocrests. like andesite, and more mafic minerals such as biotite, hornblende, and pyroxene, and as a ground mass of also a little quartz. A little quartz. So it's a pretty dark rock. It is named after the Andes Mountains in South America and is usually formed near subduction zones. So these are the minerals you can find in it: andesite, biotite, hornblende, and pyroxene. I'm not going to go over where all of these were found and how big the picture is. Most pictures are only 4 millimeters, so. And all the pictures of the minerals are my own. The next rock is anorthosite. It's an intermediate plutonic rock that consists of more than 90% plagioclase, either bitonite or labradorite. In addition to plagioclase, the igneous rock anorthosite contains a few other minerals, but mainly quartz and potassium feldspar. There are no feldspar substitutes in this type of rock. On Earth, enormous distributions of the plagioclase-rich igneous rocks are known. For example, Mount Lister in Labrador, Canada, covers many thousands of square kilometers of anorthosite. So these are the minerals in anorthosite: quartz, orthoclase, microcline, and labradorite. Apatite. Apatite is an igneous rock that consists almost entirely of the minerals quartz and potassium feldspar. So it's a pretty white rock. Apatites are usually very fine crystalline, white-gray or flesh-colored, and the rock-forming minerals are only visible with the help of a magnifying glass or even a microscope. Apatites are mainly found in the vicinity of granite masses, mainly, through which they cut like dice. If you can see the guy standing on top of a granite massive, you see the white ribbons crossing the granite. That's an apatite. But they can also be found in cyanides, diorites, and gabbros, which are other igneous rocks. Well, here's a quartz, microcline, orthoclase. You may have seen the picture before because I don't have that many of those materials. Well, basalt. That's an interesting one. It's a mafic igneous rock that is formed by the solidification of lava. The solidification takes place at the Earth's surface, so therefore it is an extrusive rock. Basalt discharges can also take place underwater, for example at the mid-ocean ridges, and it's the most abundant rock on Earth. About 70% of the Earth's crust consists of basalt. The name basalt is derived from the ancient Greek basanites or basanos, which means a stone from Bashan. No idea where that is. The grains in basalt are usually too small to be seen with the naked eye, but it can be porphyric or contain cavities, which are called vesicles, that form when gas bubbles expand in the solidifying lava. These rocks with empty vesicles are called vesicular basalt. Once the lava has solidified, water seeping through the lava often begins to fill many of these cavities with mineral crystals. These fills are called amygdules, and therefore the basalt is called amygdaloidal basalt. They can have a diameter of approximately from 1 millimeter to 30 centimeters and usually contain quartz, carbonates, and zeolites. You see examples of aragonite, quartz, stilbite, and thomsonite. There is a wide range of basalt rocks which can be divided into two large groups according to their chemical composition. The tholeiitic basalts, poor in peridot and rich in calcium-poor pyroxenes such as andesite and pigeonite, and alkali basalts that contain more potassium and sodium and are rich in olivine, nepheline, and augite, which are these minerals. Basanite is a felsic extrusive rock rich in alkali metals. The rock contains mainly feldspar substitutes and plagioclase, but also clinopyroxenes and olivine. And the word basanite is derived from the Greek basanos, which means touchstone. However, not basanite, but lyddite is used as a touchstone. Here you see the sodalite, forsterite, diapsite, and albite crystals, which can form in basanite. And a weird one, carbonatite, is a rare form of igneous rock which consists of more than 50% of the mass of carbonates, such as calcite, dolomite, or anchorite. Sometimes also from rare carbonates, such as anchorite, nyererite, or grigoriite. Due to the low concentration of silica, carbonatites often contain minerals such as laterite, sodalite, galenite, forsterite, diapsite, and azurine. Other possible silicates are phlogopite, potassium feldspar, amphibole, zircon, vermiculite, wollastonite, and titanite. Here are the normal carbonates, and here you have the rarer ones. And the minerals which go with it are arfvedsonite, azurine, galenite, and natrolite. Zircon, vermiculite, titanite, and wollastonite. Dacite. This is a rock with less quartz than rhyolite, so it has less quartz, 20% less. No, it has only 20% made up of quartz, and it has an intermediate composition between rhyolite and andesite, with rounded phenocrysts of andesine and labradorite as feldspar instead of cyanidine. The picture you see on the right-hand side is a thin slice of the rock, which shows the crystals better. Andesine and labradorite, yes. Diorite. Diorite is the coarse-grained equivalent of andesite, and the minerals with a reasonable crystal size that occur in diorite include pyroxene, amphibole, plagioclase, muscovite, and biotite. Diorite is a deep organic rock that becomes exposed during tectonic uplift during orogeny or mountain building. So heavy pressure and temperature changes forms diorite. It is formed in the core and magma corridors of mafic volcanoes. It contains Higgenbergite, actinolite, tetraferri phlogopite, and muscovite. Well, pretty names, but tetraferri phlogopite is actually a fancy name for a dark mica. Dolerite, also called diabase, is a mafic gangue rock with a silica content between 48 and 52%, so half-half. Dolerite is a medium crystalline gangue rock, the mafic equivalent of the felsic gangue rock granophyre, which we'll be speaking later on. Dolerite is formed from less viscous magma than granophyre, and the minerals that are usually found in dolerite are olivine, plagioclase, biotite, amphiboles, and pyroxenes. Dunite. Dunite is a type of peridotite that contains almost exclusively of olivine, more than 90% olivine in this rock, with small amounts of andesite, diapsite, pyrope, and spinel. It is named after Dun Mountain, a grey-brown mountain in New Zealand, because the rock, green when it comes to the surface, turns brown due to weathering. And you can see it here already happening on the outside of the rock. The crust is beginning to turn brown. It is rich in several rare minerals and is the world's main source of chromium ore. Gabbro. Well, gabbro is a mafic plutonic rock that contains also 48 to 52% silica. and it's the mafic equivalent of granite and the plutonic rock equivalent of the outflow rock basalt. Deeper and therefore slow cooling has resulted in relatively larger crystals than in the gangue rock dolerite. The minerals we find in gabbro include olivine, pyroxene, amphibole, magnetite, and biotite. Light-colored plagioclase also occurs in the usually dark gabbro rocks. I just put together a bunch of minerals which can form into gabbro, so you have an idea of what minerals you can find in that type of igneous rock. Well, granite. Well, granite together with basalt is the most common igneous rock on Earth. Granite is a light-colored, mostly pink, acid rock with a high silica content and a high quartz content. More than 20% quartz and more than 70% silica. The rock is essentially a mixture of white and pink feldspar, pale quartz, and small speckles of black mica. Because granite is slowly formed deep underground by cooling, the crystals are almost always large enough to be seen with the naked eye. Most of them are at least a few millimeters, but the largest white feldspar crystals can be as long as 20 centimeters. Well, different types of granite have emerged. The first type is mainly formed in the continental crust, which can be several tens of kilometers thick. This type of granite is formed by the solidification of partially molten rock in the Earth's crust, usually at a depth of more than 2 kilometers below the Earth's surface. The intrusion of magma from the Earth's mantle causes partial melting of parts of the Earth's crust. And during the solidification that takes place afterwards, which can take millions of years, creates granites. The slower the solidification takes place, the more time there is for complete crystallization, which can cause large alkali feldspars. Solidification of alkali feldspars starts at a temperature of 11 to 1200 degrees Celsius, and quartz only solidifies at a temperature of 600 to 650 degrees Celsius. As a result, the quartz can often no longer form crystals because there is no more room for it, and can only fill the spaces between the minerals that have already formed. Partial melting of the continental crust is the most common process of granite formation. A second type of granite originates in the so-called subduction zones at the edges of the continental plates. When two continental plates collide, the edges of one slide under the other and can be pushed so deep into the Earth's crust that partial melting takes place of plutonic rocks deep in the Earth's crust. The resulting magma often forms large battleites, which are bodies above the mantle, in the Earth's crust, creating granites with a lot of biotite, and transitions to granodiorite, where the dark mineral consists mainly of hornblende. Well, granite can be found all over the world in all kinds and colors. For example, in some parts of Belgium, where most of the extractable granite has already been commercially mined, so they're running out of granite. And some erratic boulders in the north of the Netherlands, in Drenthe, consist of granite usually brought here by glaciers from Norway or Sweden. The largest exporter of granite in the world is India. But there are other important granite quarries in England, Norway, Sweden, Finland, France, Spain, Portugal, well, actually all over the world. Granodiorite is the intrusive equivalent of dacite with a high silica content, approximately 65%. It's a depth gangue rock that becomes exposed during tectonic uplift, like during orogeny, and it is formed in the core and magma corridors of dense volcanoes. Minerals with a reasonable crystal size that occur in granodiorite include quartz, amphibole, plagioclase, potassium feldspar, muscovite, and biotite. Quartz porphyry is actually an inaccurate name for a rock with the same chemical composition as rhyolite and granite, with phenocrysts of white quartz and red feldspar. Quartz porphyry usually consists of minerals such as quartz, potassium, feldspar, and plagioclase. Lamprophere. Lamprophere is a fine-grained gangue rock with large phenocrysts of mica, amphibole, and olivine. Feldspar phenocrysts are absent in this rock, but are present in the ground mass. So there is feldspar in this rock, but not as phenocrysts. They occur in tunnels in tonalite and granodiorite plutons. The name is taken from the Greek words of shimmering mixture. This is a nice one. This one I like. Larvikite. Larvikite is a variety of monzonite that contains specific plate-shaped groups of feldspar, creating a kind of rainbow shine. Other minerals that occur in larvikite are barkitite, which is the wrong name. It's actually ferroedenite, and titanium-containing augite and dark mica. The name comes from an area around Larvik in southern Norway. Well, monzonite. Larvikite was a monzonite. This is also a monzonite. This is a plutonic rock that consists of equal parts clevelandite, which is actually albite, a variety of albite, and autoclase feldspar, and contains a small amount of quartz. It also contains hornblende and biotite for the darker materials. There are three types of monzonite depending on the presence of quartz. It's a quartz monzonite, nepheline, it's a nepheline monzonite, or olivine, and it's an olivine monzonite. The name comes from an area in Monzone in Tyrol, in the northern part of Italy, near Monzoni. Nephelinite is a fine crystalline igneous rock consisting almost entirely of nepheline and clinopyroxene, in this case augite. If a nephelinite also contains olivine, it is called a peridot nephelinite. They're usually dark colored and may initially resemble basalt. Basalts, however, do not contain nepheline, but plagioclase and amphibole. So you see, it's difficult to distinguish the different igneous rocks from each other. And only by the mineral content you can get them apart. Nepheline cyanide is a plutonic rock consisting mainly of alkali feldspar and nepheline, and contains no quartz at all. The good examples of plutons with nepheline cyanide in it are in the Kola Peninsula, the Kibini and Lobozero massives. It may also contain the following minerals: riebeckite, arfvedsonite, ferroedenite, azurine, and azurine augite, and accompanied by minerals like sodalite, cancrinite, howine, nocian, apatite, and titanite. Again, there are many varieties of nepheline cyanide, each with its own characteristics. These are the minerals that can form in the nepheline cyanide. Norite. Norite is a mafic plutonic rock consisting mainly of labradorite, andesite, and olivine. It's an igneous rock that is mainly associated with platinum ore bodies, so it's geologically interesting, which are in South Africa, and the Skagerrak complex in Greenland, and the Stillwater complex in Montana. Norite is also found in the Sudbury Basin complex in Ontario, where there's an impact crater, and is the world's largest nickel-bearing mining area in the world. Fun fact, norite was also found on the moon and brought to Earth by the Apollo missions. I even put in a little platinum grain on my bottom view. Well, also textures play a part in the classification of igneous rocks. Obsidian is a naturally occurring volcanic glass. It's a vitrified rock from rapidly solidifying lava that consists mainly of silicon dioxide, 70 to 75% of it, and large amounts of magnesium and iron salts, mostly periclase and hematite. The name obsidian is derived from Opsius, which is the name of a Roman guy who is said to have found an obsidian-like stone in Ethiopia in ancient times. A particular obsidian form is the snowflake obsidian. It contains inclusions of spherical structures, mostly of feldspar or crystal baelite, which are called spherulites, where I already gave a presentation about spherulites. This is a nice one. Pegmatite. Well, pegmatites are the creme de la creme of igneous rocks. They contain very large crystals, larger than 2.5 centimeters, have a high silica content, so are felsic, and consist largely of quartz, feldspar, micromount, and mica, which is muscovite. So not very much different than granite, but with larger crystals. Pegmatites from bodies like veins, dikes, or lenses, which are usually no larger than a few hundred meters long, but tens of meters wide. So they are significantly, and most pegmatites have the same mineralogical compound as granite, like I said, only larger crystals. However, they also occur with the same compound as cyanide and gabbro. So these are the normal minerals which you can see in a pegmatite. Pegmatites form very deep in the Earth's crust, 6 and 9 kilometers deep, and the accession size of the crystals range from 1.3 centimeters to 13 meters. There are several pegmatites in Brazil which show these 13-meter long feldspar crystals, topaz crystals. Amazing. Well, they may form by solidifying the last very silica-rich remnants of magma after crystal fractionation, which penetrates the crust along fractures and joints. Since such residual magmas are rich in volatile compounds such as water, hydrochloric acid, and hydrogen fluoride, this may explain the extreme size of the crystals. This hypothesis also explains that pegmatites often contain relatively rare minerals, because a residual melt will be enriched in rare incompatible elements such as beryllium, niobium, rubidium, cesium, gallium, tin, and tungsten. Up to date, there are more than 550 different minerals found in pegmatites. Pegmatites are also a source of many gemstones. In addition to famous topazes, beautiful garnets, one can also find all varieties of beryl, tourmaline, and spodumene. I've got some examples of beryl and topaz and tourmaline. There are actually two types of pegmatites, the simple and the complex ones. The simple ones are essentially very coarse-grained equivalents of the parent rock, so granites and such, which consist of the same three basic ingredients and also a little tourmaline. The complex ones, such as the LCT pegmatites, are rich in lithium, cesium, tantalum, beryllium, phosphorus, and fluorine, and the NYF pegmatites rich in niobium, yttrium, fluorine, titanium, thorium, and uranium. They contain the rarer minerals. So here you see examples of the lithium ones, and also tin. And these are the ones, the NYF pegmatites. The next igneous rock is peridotite. It's a coarse, crystalline, ultramafic rock with high density, consisting mainly of the minerals olivine and pyroxenes. So it's again a very dark rock. It is a mantle rock and contains less than 48% silica. It's also rich in iron and magnesium. so therefore dark minerals. Perlite. Well, perlite is also a naturally occurring volcanic glass, but unlike obsidian, it contains water, 2 to 5% volume percent of water. Perlite is being used in gardening a lot. Phonolite. Well, phonolite or sandstone is a greenish-gray colored extrusive rock that contains a lot of alkaline minerals, such as potassium feldspar and more than 10% of nepheline. In addition to nepheline, it also contains feldspar substitutes, azurine, amphibole, and biotite, but does not contain quartz. The name of the rock phonolite is derived from the Greek words phono, sound, and lithos, which means stone, so soundstone. The rock is formed in the East African Rift, among other places, but you can also find it in the German Eifel, the Azores, and the Massif Central in France. Massif Central. Pickrite. Pickrite is an extrusion rock with a chemical composition like basalt, but with more than 25% olivine. The olivine crystals are usually phenocrysts in a fine-grained matrix. In addition to olivine, it contains augite, hornblende, biotite, and plagioclase. It is also known as oceanite, and it is formed on Mauna Kea and Mauna Loa in Hawaii and the Piton de la Fournaise on Réunion. Pumice. Pumice, or as the Germans say, Bims, is a volcanic rock characterized by a high porosity. Due to the large number of small cavities in the rock, it is very light, and many varieties of pumice can float on water. So a rock that floats. Pumice is common in the Eifel, and I've been there myself many times. And you can see all the layers of pumice in the rocks, the sheer straight up rocks in there. They're very stunning to see. Pyroxenite is an ultramafic rock that's formed from magmas that develop deep in the Earth's crust. It contains a large amount of clino and orthopyroxenes, such as augite, andesite, or ferroedenite instead of olivine. Rapakivi. It is actually a variety of granite, well, a cyanogranite, which is characterized by the very large phenocrysts, 1 to 5 centimeters, of orthoclase, sometimes with a ring of oligoclase. And the groundmass consists of quartz, feldspars, and mafic minerals. Rapakivi is a globally occurring variety, but is mainly found in geologically very old continental crust, like the Precambrian Baltic Shield. Within Europe, it's mainly found in Scandinavia and especially in southern Finland, hence the name. Rapakivi massifs also occur in Sweden and Karelia. Rhyolite, or aged liparite, is a granite-like volcanic igneous rock with a felsic composition. It's an extrusive rock and consists of more than 68% of silica. The name rhyolite, formed from the Greek words Rhine and lithos, a stream stone, because when it is formed, it flows. Rhyolite usually consists of quartz, potassium feldspar, and plagioclase, but can also have traces of more mafic minerals like biotite, amphiboles, and pyroxides. Cyanide. Cyanide is a coarse-grained crystalline igneous rock that is saturated with silica dioxide but contains little to no quartz. It belongs to the deep rocks. The minerals found in cyanides are mainly orthoclase, biotite, amphibole, and pyroxene, but can also contain plagioclase. The color of the rock varies from blue-gray or red to dark green or black, so multi range of colors. Outwardly, it resembles granite, but it is in fact the quartz poor variant of granite. Tonalite. Tonalite is a felsic plutonic rock with a chemical composition like that of granite, only without potassium feldspar. Actually, there are very little alkali feldspars in that rock. It usually contains more than 20% quartz and plagioclase, amphibole, and pyroxene. And it's named after the area of Tonale in the Italian Alps near Monte Adamello. Trachyte. Trachyte is usually a gray extrusive rock and contains small amounts of quartz and niflheim, in addition to potassium feldspar, pyroxenes, and amphiboles. The name of the rock, trachyte, is derived from the Greek trachus, which means rough, and it's because of its appearance. It looks like a rough stone. Trachytes occur in volcanic regions that have alkaline-rich volcanism. The rock is formed in the Great Rift Valley and in the Eifel, the Azores, Tenerife, and the Black Hills in South Dakota, US. Troctolite. Troctolite is a weird one. It's a gabbroic rock that contains virtually no pyroxene. Well, virtually no, less than 5%. And it consists of plagioclase and olivine. Troctolite is also called trout stone, because if you look at the picture, you can see almost what looks like the skin of a trout. The rock is found in layered igneous complexes such as Bushveld in South Africa, Bushveld, and the island of Rum in the Scottish Inner Hebrides. The Rum complex was created about 60 million years ago during the birth of the North Atlantic Ocean. Right. The sources I used, well, I did use online sources like Mindred, Mineralian Atlas, Wikipedia, and also a Dutch site, which is called Zwerfsteen Web, which contains all the rocks you can find in the Netherlands, which are brought here mostly by the glaciers during the Ice Age. And of course, I used books. I still have books, Rocks and Minerals, Guide Rocks, and Discovery in Geology. They are all in Dutch, so probably not for most of you, but. And this concludes my presentation. I hope you enjoyed it.